Alrighty, today we're doing 4.2 notes, which is modeling and density. So we've combined chapter 3 and chapter 4 because they're both about geometry. So you might want to grab this handout right here that we gave you already for these problems because they have a lot of the volume and surface area formulas that we're going to need. So let's go ahead and take a look at our first definition. It says density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. So to find density, we just need to know the mass and the volume. Density can be used to help distinguish between similar materials. So first example, 2 wooden logs can be modeled by cylinders. So we're going to be looking at cylinders whose dimensions are shown in the table below. So for the cylinder, we have the mass of the Douglas fir log and we have the mass of the American redwood, but we don't have the volume, so we would have to refer to our formula right here for the volume of a cylinder, which is pi r squared h. So we need r and we need h. So we come look at the information that they give us. The height is very visible, it's right there. But they give us the diameter. We're intelligent enough to know that the diameter is twice the radius, or another way to say that is that the radius is half the diameter. So that leads us to that right there. If we want to know which one is more dense, we got to see which one has the bigger density. So we're going to start with the Douglas fir. And we know that density equals mass over volume. I'm going to abbreviate volume. So we take the mass, which is 254 kilograms, and we divide it by the volume. Now the volume of a cylinder is going to be that formula that we just looked at, which is pi r squared h. Okay? So that's what we're going to plug in right here. So we have pi, and then r squared, so 3 squared, and then the h that goes with that is 17, and we're keeping our units, and so this is going to be centimeters cubed. And the reason it's cubed is because we have r squared, so centimeters times centimeters, and then we're multiplying it by the height, which makes it cubed. And we are going to plug that into our calculator to figure out. So 254 divided by, and I'm putting all of this in parentheses, so we have pi times, what is that, 3 squared, which is 9, times 17, and then I'm closing out the denominator, and we get 0.528, and we are rounding to 3 decimals, so 0.528, and the units are the numerator, kilograms per centimeters cubed. Okay, so there's that one. So that's the density of the Douglas fir. Now we have to do the American redwood. So again, density, that's that mass divided by volume. So the mass of the American redwood is 271, and the volume is going to be calculated by using pi r squared h. Since it's a log, it's a cylinder. So we have pi times 4 squared, sorry, this is kilograms, I didn't put that, times the height of 12, and that's centimeters cubed. So we're going to plug that into our calculator, boop, 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 and we get 0.449 kilograms per centimeters cubed. And so then it says, given pieces of wood with the same dimensions, the Douglas fir would be heavier than the American redwood. And that is because if you look, I'm going to move that up, don't trip. If you look, 0.528 is bigger than 0.449, so the Douglas fir is more dense. And if it's more dense, then if everything else is equal, then it's going to be heavier than the American redwood. All right. So the next one says the density of aluminum is this, 28,000 kilograms per meters cubed. What is the mass of a solid cube of aluminum? So we're looking for the mass with side lengths of 0.5 meters, and we have a solid cube. So let's start with the density formula. So density equals mass over volume. So right away they tell us the density is 2800, so we need to make sure we plug that in the density spot. Kilograms per meters cubed. We need to make sure our units cancel, that's why we're writing them. And then we have our mass, which is what we're looking for. What is the mass? So we don't know what that is. Of a solid cube with side lengths of 0.5 meters. So if you don't know the formula for the volume of a cube, you have this sheet right here, and it says right here that the cube is volume, the side length cubed. Okay, so we just need to take this, do 0.5 cubed, and since it's meters, the unit will be meters cubed. Okay. So we're solving for the mass. So because this and this are going to cancel out, and then I just need to multiply. So the reason why it cancels out, here, let me do it this way. So I'm multiplying both sides by 0.5 cubed meters cubed because I want to solve for mass. So if I want to solve for mass, I cancel those out. And then look, now that's in the numerator, it'll cancel that out. So really the mass, which is the only thing left over here, is equal to 2800 times 0.5 cubed, and then the only thing that's left is kilograms, which makes sense because it's the mass. So then I'm going to do order of operations, 0.5 cubed, and then I'm going to times it by 2800. And I get a mass of 350 kilograms. Not bad. Okay, so that is density of objects. Next, we're going to go into population density. So that's how big, how many people you have in your population divided by the area that they're in. And just a friendly reminder, this is the area of a trapezoid. It's going to be 1/2 the height, and then base 1 and base 2. So, like, there's a trapezoid, this is base 1, this is base 2. It really actually doesn't matter which one you label which because they're both in the formula, but that's what the area of a trapezoid is. And trapezoids come in all different shapes and sizes. So the state of Delaware has a population of 917,000. Delaware's territory can be modeled as a trapezoid as shown below. So here is our trapezoid. So we have this side that's a straight line right here. Up here in my picture it was a slanted one, but that doesn't make it not a trapezoid. It has 4 sides, they're not congruent, blah blah blah. You know what I mean. Okay, so it says use the area of the model to approximate the population density. So we're trying to find the population density. So we have to take the population and divide it by the area. So let's go ahead and calculate the area of this trapezoid. So we need to be really careful and label our bases and our height appropriately. So our height is clearly 80. We'll call this base 1, and it goes from 0 to 20. So you're ignoring the 80 because you're looking at the horizontal distance, not the vertical distance. And then this, base 2, is 40. So if I'm going to find the area of this trapezoid, it's going to be 1/2 the height, which is 80, times the base 1 plus the base 2. Okay? So whatever that is, when I do that math, it's the same thing that's going to go down underneath the area. So I'm going to write it there too so that you can see where I got it from. And then we're going to simplify. But what's the population? They tell us right here. This is 917,000. And the unit is people. And then here it's the area, and we are in miles. So this is going to be miles squared because you're doing two-dimensional. It's not three-dimensional. Alrighty, so then we're going to plug this into our calculator. So if you want to simplify this first, so I'm going to do, we know 20 plus 40 is 60, times the 80 equals 4,800, times 1/2 is 2,400. So always units. This is like the real life application that you guys don't like. Or you say you want and then you don't like because you have to do units. So, and fractions, they're never nice clean numbers. 917,000 divided by 2,400 equals 382 people, we'll say. Per miles squared. So for every square mile, they'll have 382 people in there. All right. Okay, area of a parallelogram. So again, you have this formula. We have it on our notes, but here's the area of a parallelogram. Base times height. So we're going to be using it for this one. Chicago has a population of that many people. Its territory can be modeled in the as shown in the figure. Find the approximate population density of Chicago. Round to the nearest 100 if necessary. So we need to figure out what this is right here, and since it's a parallelogram, we kind of already know. Also, notice the height of the parallelogram is that straight line that makes the right triangle. So we can use this one. We could also use that guy right there. But we can see these are going up. You have to watch your scale. So my height, my height is what? It looks like it's 20. And then this is a distance of 10 because it goes from 5 to 15. Okay, so for the population density of Chicago, we're going to take the population over the area, which means the population is 2,715,000 people. That's our unit. Divide it by the area, which is in miles, so that's going to be the base of 10 miles, the height of 20 miles, and that's going to be miles squared, because when you multiply miles by miles, you get miles squared, and then we are going to plug it in to the calculator, and we get 13,575 people per miles squared. And then the directions, just to make sure we're meeting everything, say round to the nearest 100. So we have ones, tens, hundreds is this one right here. That 7 is going to round that up to a 6. So my HRW might ask you to round this to the 100, so you have to follow the directions, otherwise you might not get it right. Okay. So that one was Chicago. That's a little bit more dense, I'd say, than that little tiny state of Delaware, which is crazy, but makes sense also. It's a big city. So let's flip it over onto the back side. According to a 2010 census, San Francisco has this as its population density. This is their total population. How large is San Francisco to the nearest 10th of a square mile? So remember, population density is population over the area of the location. We know the density, so we need to plug that in the proper spot, and that's people per mile squared. And we know the population is 805,235 people, but we don't know the area, right? So if we don't know what the area is, we are going to try and solve this by working backwards. So I want to know what the area is. So the first thing I'm going to do, just to make my life easier, what I'm solving for is in the denominator. So if I multiply out the area, then these cancel. And now area's in the numerator, but I want this to be by itself, so I'm going to divide this out. So area equals 805,235 people divided by 17,246.4 people per miles squared. Because the people are both in the numerator, when they're on opposite sides, they're going to cancel. And then this is going to copy dot flip up into the numerator. Just the miles squared, because it's the only thing in the denominator. So then I'm going to plug that into my calculator. 805,235 divided by 17,246.4 equals 46.7 miles squared. And it says round to the nearest tenth, so that's why it's miles squared. You should also know, like right here it tells you, if you're like, I don't know which unit, square mile, that's the way you write square mile. Okay, so it already tells you. Okay, our last set of definitions, a British thermal unit, which is a BTU, is a unit of energy, and it's approximately the amount of energy needed to increase the temperature of 1 pound of water by 1 degree Fahrenheit. The energy content of a fuel may be measured in BTUs per unit, so it could be like a propane tank or something like that, like a lot of camping stoves are in BTUs. So also, like even when you go to buy a stove for your kitchen, it could be in BTUs as well. The other one we're going to need for this one is the volume of a sphere. So we put it right there, but as a friendly reminder, your volume of a sphere is right here as well on your handy dandy shapes handout, which you will have at your disposal on the test. Okay. So a spherical tank is filled with a gas and it has the dimensions shown. So right away, I'm seeing 6 feet, and I'm automatically going, that's the diameter, so my radius is 3 feet. If you're like, how do you know that? If they just want the radius, they'll actually put just a line on halfway through. When the tank is filled with ethanol, it provides this many BTUs. Find the number of BTUs produced by 1 cubic foot of ethanol by using a proportion to approximate the number of BTUs in 1 cubic foot of ethanol. So that is really wordy and you might be like, what the heck? So what we're going to do is we're going to set up BTUs over 1 cubic foot. So 1 cubic foot would look like that. All right. And we're setting it up to say the BTUs in the tank over the volume in the tank. Okay, so we're getting this because BTUs says the energy content in fuel may be measured in BTUs per unit of volume. Okay, so that's where the volume is coming into play. So we're setting up this proportion. This doesn't need, we're solving for BTUs. We already have a number here. The BTUs in the tank is given. It's that 1,149,069, and that's British thermal units. So that one's BTUs. And then the volume in the tank, because the tank is a sphere, then we just use this formula, 4/3. And then pi r cubed, and r is 3, and it's cubed, so then that's going to be feet cubed. Okay, and it's feet because this is feet right here. right? Okay, so then we would end up seeing these are both in the bottom. So the number of BTUs, these are going to cancel. And we have to plug this into our calculator. So just make sure, if you want to use that fraction feature, you can. Otherwise, what I always suggest you do is not suggest, you have to do it. It's not a suggestion. Anytime you want to type a fraction into a calculator, always make sure to put your numerator in parentheses and your denominator. So this is 3 to, I'm going to do times pi times 3 raised to the third power. And I get 10,160.00063. So the number of BTUs is going to be that number right there, 10,160.00063 BTUs. So in 1 cubic foot, there will be, when we simplify that, 10,160 BTUs in 1 cubic foot of ethanol, which is what they asked us right there. Okay, so we're going to do the same thing, but now when the tank is filled with a natural gas, it provides this many. So at first it was filled with ethanol, and now it's natural gas. So we have BTUs per 1 cubic foot, so 1 foot cubed, and then we plug and chug in that. The tank is the same tank, so it's the same area. So it's still going to be 4/3, whoa, that's not a 3. 4/3 pi r cubed, and r is 3, and the unit is feet cubed. And then we plug that into our calculator, and we get 1,027.00032 BTUs, which means it's just going to be in 1 cubic foot of natural gas instead of ethanol, there's 1,027 BTUs. So it's a lot more BTUs than ethanol. Alrighty, and that is it for today's lesson.